Morning, everybody. I'm going to show you data for the Inertial Balance lab. So essentially you're going to look for the relationship between the period of oscillation and the mass, and we're going to use that relationship to predict the mass of an unknown. In this case, it's going to be our friend Woody. So the following videos are going to look at different masses, and you're going to have to count 20 oscillations and time how much time it takes for the balance to do that. For the first trial, it's going to be very quick, so you can maybe have to do a few practice trials and understand that maybe you didn't quite count 20. So if you see a data point on your graph that is an outlier, that might be the reason why. So here is the apparatus. Okay, so this is an inertial balance, and it oscillates back and forth, and how fast it oscillates back and forth, or the time, depends on the mass. And so we're going to use it to distinguish the inertial mass and gravitational mass as explained in the theory part of the lab. And one last thing, when you're counting, it's complete revolution. So if I'm pushing my inertial balance this way and I release it, it comes to the right, at least the one I'm looking at, and it goes back. So when it gets back to original point, that's your first vibration or oscillation. Okay, good luck. When you do your first graph, you should be getting a nonlinear relationship. It might look a little bit linear, but it's not. And I'll even give you a spoiler, it should look like a bit of a square root. Depending on that first two data points, which could be iffy, it might look like a quadratic. It's not. It's supposed to be a square root. So when you go to linearize it, use that, or keep that in mind so you do it properly. Good luck.
All right, this is going to be our first measurement for the period of inertial mass. I've added 100 grams. So that is your first data point, 100 grams added mass, not the total mass. All right, so do your best to count 20 oscillations, and I will begin it now. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Second trial, now we've added 300 grams, again for 20 oscillations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Third trial, now we have 500 grams added mass. Okay, fourth trial of added mass, we now have 700 grams added. And our last trial, we now have 1,000 grams or 1 kilogram added. So now we're going to use your equation you developed from the 5 previous masses and measure the period for Woody here as he oscillates to predict what his inertial mass is. So again, count 20 oscillations. I will let it go for probably a little bit more than that. And then once you have that period, you want to compare it to, or excuse me, you want to use that period and your equation to predict its mass, and then we'll compare it to his gravitational mass. Here we go. Ready, go.